3 sides of a triangle congruent? Is that at least 2 sides? Yes. So even if I have 3 sides congruent, it's still considered an isosceles triangle. But for the purpose of this class, whenever I say it's isosceles, it will mean that 2 of the sides are congruent. And it doesn't matter which 2 sides are congruent. Does not matter which 2 sides are congruent. As long as there's 2 sides congruent, it is isosceles. Okay, so the reason I said for an isosceles triangle, we'll always just say it's isosceles if 2 sides are congruent, because there's a better word if all 3 sides are congruent. Does anybody know what it is, Noah? You got it. An equilateral triangle is a triangle in which all the sides are congruent. And now something you don't know. If a triangle is equilateral, I'm going to use a different word, it is also equiangular. So if equilateral means all the sides congruent, any guesses on what equiangular means? All the angles are congruent. So if I have an equilateral triangle, I can immediately say it is also equiangular, which means all these angles are congruent. And who remembers, if I add up all the angles in a triangle, what number does that have to add to? Every time I add up all the interior angles in a triangle, it always adds to a number. Jack. Double that? 180. You got it. So this is actually something you need to know the whole year. If you always add up the angles in any triangle, it will always add up to 180. So now if all these angles have to be congruent, but they also have to add up to 180, wouldn't we do 180 divided by 3 to get 60 degrees for each angle? So if a triangle is equilateral, it is also equiangular, and each angle is 60 degrees. And there we go. The sum of the measures of the 3 angles of a triangle is 180 degrees. So when we classify a triangle by its sides, we have scalene, isosceles, and equilateral. What does scalene mean? Somebody knew. What does scalene mean? Jay? So none of them are congruent. Perfect. What does isosceles mean? Somebody knew. Jonah. 2 of not angles. We're going to say 2 of the segments. 2 of the sides are congruent. So scalene is no sides congruent. Isosceles is 2 sides congruent. What is equilateral? What is equilateral? Sebastian? All the sides are congruent. So that's how we classify based on angles. Based on sides. Now we're going to talk about classifying based on angles. So an acute triangle is a triangle in which all the angles are acute. And an acute angle is, who remembers the restriction? So an acute angle has to be bigger than some number, but less than another number. Stella? Isn't it just like bigger? Yep, greater than 0 and less than 90 degrees. So if we have an acute triangle, we're talking about the angles. All of those angles are less than 90. They're nice and small and cute. Okay, a right triangle is a triangle in which one of the angles is a right angle. Why am I not able to have 2 of the angles be right angles? Any ideas? Any guesses? So I said, if you have 1 right angle, then it's a right triangle. Why can't I have 2 right angles in a triangle? Jonah? Say it one more time. Good. Why? You're right. Why? So think about the angles in a triangle. What does all the angles in a triangle have to add to be? 180. So can I have two of those angles by themselves adding up to 180? No, never. So we could only have one right angle in a triangle, but if we have that one right angle, it is then called a right triangle. And the very last one is called an obtuse triangle. And who remembers what an obtuse angle is? Bigger than what and smaller than what? Leilani? You got it. So an obtuse triangle has to have one obtuse angle in it. A right triangle has to have one right angle in it. An acute triangle has three small acute angles that are all less than 90. Okay, parts of an isosceles triangle. So anytime we have an isosceles triangle, we know two sides are going to be congruent. And those two sides have special names. So the two sides that are congruent are called the legs. So here, see how I marked A, B, and BC congruent? AB is a leg and BC is a leg. So here, A, B, and BC are the legs. They're always the parts that are congruent are called the legs. And guess what? The side that's not congruent is called the base. So AC is called the base. So the two sides that are congruent are called the legs. The side that's not congruent is called the base. And guess what? The base angles are on which side? Any guesses? The base angles will always be on the base, right? The base angles will always be on the base. Which side is the base? AC. It's not always the bottom, but in this scenario it is. So this side is AC. It's the side that's not congruent. And since AC is the base, the two angles that are on the base are called the base angles. So angle A and angle C are the base angles because those are the angles that are on the base. And then we have one more part. It's called the vertex angle. So basically the angles that are not on the base is the angle that's not on the base is called the vertex angle. It's also the angle that the two legs make. So if the two legs come together to a point, that will always be the vertex angle. So in this scenario, it's angle B. All right, so let's go to example 2 because I marked it a little bit differently. Can somebody identify the two legs for me in example 2? Caitlin? You got it. YX and YZ because they're marked congruent. And since YX and YZ are the legs, which one has to be the base? Jack? You got it. XZ is the base. Nope, doesn't matter. ZX, XZ are the same thing. And if XZ is the base, which angles are the base angles? So if XZ is the base, which angles are the base angles? Stella. You got it. Angle X and angle Z. And that leaves which angle to be the vertex angle? Which angle is the vertex angle? Caitlin? Angle Y. You got it. All right. So those are all the parts of an isosceles triangle. Now let's talk about the parts of a right triangle. So remember, a right triangle has to have at least, well, not at least, it has to have exactly one right angle in it. And you guys might remember this from the middle school. The side opposite the right angle has a special name. It starts with an H. Does anybody remember? Janet? The hypotenuse, you got it. So the side opposite the right angle is the hypotenuse. And the side that come together to make the right angles are called the legs. Now, the legs in a right triangle are different, so I'll call it leg 1 and leg 2. The leg in the isosceles in a right triangle are different than the legs in an isosceles triangle. In the isosceles triangle, the legs are congruent. The legs are not necessarily congruent in a right triangle. They're just called legs. Okay. If you guys remember when you looked yesterday, there's a whole section like this on your graded assignment. So let's go through this and make sure we know how to do this. So first, be sure to know that the diagrams are not drawn to scale. And we want to classify the triangle in two ways, one by its sides and part B by its angle. So right now, do you see in number one how I marked these two with the same marking? Since those two are marked with the same marking, doesn't it mean that those two sides are congruent? Is the last side also congruent? No, because that has two slashes while the other ones just have one slashes. So only two sides are congruent here. What do we call a triangle with only two sides congruent? Isosceles. And I write isos. You could write isos if I write isos. Okay, and now the second thing we have to do here is classify it by its angles. But you cannot classify a triangle just with two angles. You need that third angle. And I only have 40 and 40. Does anybody know how I would find the third angle before I decide to classify this? Noah? Good. Remember, a whole triangle has to add to 180. So I already have 40 plus 40. So 40 plus 40 is 80. And then what I want to do is 180 minus 80, which is 100. So since the whole triangle has to add to 100 degrees, all its interior, 180 degrees, all its interior angles, I'm able to find that last angle. So is that 100-degree angle changes everything, because isn't 100 degrees an obtuse angle? So a triangle with one obtuse angle, isn't it called an obtuse triangle? So this is isosceles and obtuse. Now, number two, I'm being really sneaky here. Do you see how I marked these two the same? So if the bottom side is 7, that side on the left, wouldn't that also have to be 7 since I marked them the same, congruent? But without the marking, didn't they also say the last side is also 7? So doesn't that mean that all the sides are congruent since they're all 7? What do we call a triangle with all sides congruent? Equilateral. And remember what we said. If a triangle is equilateral, what about its angles? If a triangle is equilateral, we said the angles were also, Leilani? Equiangular. So each angle here has to be how many degrees? 60. Good, Stella. So 60, 60, 60. And if every angle is 60 degrees, isn't that 3 acute angles? So doesn't this have to be an acute triangle? So an equilateral triangle will always be an acute triangle. So an equilateral triangle will always be an acute triangle. Okay, now let's look at the sides. Look at my markings. Are any of the side markings the same? No, if nothing's the same, what do we call that? Scalene, good. Can I say right now that this is an acute triangle? No, how come I can't decide even though 73 and 17 are both acute angles? Some besides Leilani. How come I can't say that it's an acute triangle right now? Even though, Jay? Good, because one angle's missing. We have to find that one angle. So we're going to do what Noah told us to do last time. I'm going to add 73 plus 17, and I'm going to get 90. And then I'm going to do 180 minus 90, and we're going to get 90. Well, isn't 90 a right angle? So if we have a right angle and a triangle, what does that mean this triangle has to be? A right triangle. So it's scalene and right. Okay, you guys try 4, 5, and 6 by yourself, and then we'll move on. Was anybody still copying 1, 2, or 3?
Isn't like yes, equal lateral triangle? Like because then you said it's like equal angular, so does that mean that every like equilateral triangle is the key?
Yes. And guys, what do you think about the opposite? Let's say I told you all the angles were equal. Do you think we can then say all the sides are also equal in the triangle? Yeah. So if all the angles are equal, then all the sides are equal. And if all the sides are equal, then all the angles are equal. Only in um an equilateral triangle, not everything equilateral, I should say. Okay, let's go over this. So in number 4, I see 3 markings that are different. So I know no sides are congruent. Therefore, I'm going to say that this is a scalene triangle. And then I can't decide what kinds of angle measurements it is until I find that last angle. So I'm going to add 44 plus 45. And I'm going to get 89. And then I'm going to do 180 minus 89. And I'm going to get 91. Do we all agree 91 is an obtuse angle? Is it okay that it doesn't look like it's an obtuse angle? Yeah, because remember the first thing I said, nothing is drawn to scale. So that's okay. So since I have one obtuse angle, I can say that this is an obtuse triangle. All right, in number 5, I have 2 sides marked congruent. If I have 2 sides marked congruent, what does that mean for us? It has to be what kind of side triangle? Isosceles. Now, do you guys see the box here? Isn't that a right angle? Because it's a right angle, I don't need to know the other 2 angles. I don't. Because could I ever have more than one right angle, or could I ever have a right angle and an obtuse angle? Never. So once we see that one right angle, I know it is a right triangle. And for the last one, I have 10, 10, 10. That means all the sides are congruent, so it's equilateral. And remember what we said, if it's equilateral, it's also equiangular. So every angle is 60 degrees, which means it is an acute triangle. All right, last part for today. Let's bring some algebra into this, or pre-algebra, I should say. If the perimeter of triangle EFG is 32, is the triangle scalene, isosceles, or equilateral? All right, so we need to remember, how do we find the perimeter of any figure? Good, we add all the sides. So if I add all the sides, I'm adding 2x minus 3 plus x plus 7 plus 10, and that has to equal the perimeter, which is 32. Everybody okay with how I made this equation? Now we're going to combine our like terms. So 2x plus x is 3x. -3 plus +10 is a +7 equals 32. I'm going to subtract 7 on both sides. Oops, what did I do? There was another 7 I forgot. Sorry, guys. Backtrack. Backtrack. -3 plus a +10 is a +7 plus another +7 is 14. There we go. Right? -3 plus 7 is 4. 4 plus 10 is 14. So now I'm going to subtract 14 on both sides. Borrow here. 12 minus 4 is 8. 2 minus 1 is 1. So 3x is equal to 8. Divide by 3. X is equal to 6. Okay, now that I got, I'll let everybody catch up. Now that I got that x is 6, now I could plug in. So we're going to have 2 times 6 minus 3. So this is 18 minus 3, so this is 15. And then I have 6 plus 7, which is 13. And the last side was given to us as 10. So if one side is 10, one side is 13, one side is 15, is this triangle scalene, isosceles, or equilateral? Which one? Scalene. All right, 2 more. So here it says triangle ABC is equal. Did I do something wrong? Oh, this is wrong, guys. 2 times 6 is not 18. Nobody caught that? Yes, Leilani caught it. Okay, 2 times 6 is 12. 12 minus 3 is 9. But luckily, it's still scalene. Sorry. All right, let's go on to number 8. So it's telling us the triangle is equilateral. So doesn't that mean all these sides are congruent? Sebastian? If all the sides are congruent, so it's equilateral, it's also what? Equiangular, which means every angle is how many degrees? 60. So I'm going to write that in. Okay, so here's the part that takes a little bit of thinking. The first thing they want us to do is solve for x. I'm not going to use all 3 sides to solve for x. I'm only going to use 2 of them. I'm going to use the side that has x in it. So do we agree the x plus 8 has the x in it? And then I'm going to use the side that just has the number, 15. Right? Since all 3 sides are congruent, I can use any 2 sides at a time that I want to use. So my first part here is going to be that x plus 8 equals 15. Did I lose anybody with that, how I got that equation? And then, so it's a lot easier than it looks. So I'm going to subtract 8 on both sides. So I get x is equal to 7. So it said find x. I found x. Okay, now the next part asks us to find y. So this time I'm going to use the expression that has y in it. Which expression has y in it? 1/3 y minus 6. And then do you think I'm going to use the x expression or do you think I'm going to use the number? I'm going to use the number. I don't want to deal with x's and y's, right? Since all 3 sides are congruent, I can pick and choose which 2 sides I want to use. So I'm going to use the 1/3 y minus 6 and I'm going to use the 15. So now we're going to say 1/3 y minus 6 equals 15. So my first step is to add 6 on both sides. So now I have 1/3 y equals 21. What do I do now? Who remembers from pre-algebra how to solve this? Jonah? Nope, because guys, this 1/3 y, isn't it the same as saying y divided by 3? 1/3 y is the same as y divided by 3. So this is y divided by 3 equals 21. The 3 is already being divided. So I have to do the opposite. What's the opposite of dividing by 3? Multiply by 3. Cancel those out. So this is going to be y is equal to 63. Yep. Yep. So Stella just said you didn't have to write it y over 3. She said if you had 1/3 y equals 21, you just multiply it by its reciprocal. So you could just multiply it by 3 over 1, 3 over 1 if you want to look at it that way. Absolutely. So then you would have, again, y equals 63. Same answer. And then what is A? We said all the angles are how many degrees? 60. All right, last problem. Hi, how'd your test go?
I did really well.
Yeah, I didn't get your email till this morning. I'm glad you did well, though.
I think I got like a major.
Wow, impressive.
What class is this?
Geometry.
Nice.
Yeah.
I wouldn't know.
Bye, Eli. Thanks for stopping in. All right. So here we have triangle ABC is isosceles with vertex C. Right. So here I'm being sneaky, guys. I didn't put the vertex at the top. I put the vertex here. Right. So if C is the vertex, which side's the base? Good. If C is the vertex, that means BA here is the base, which means which sides have to be congruent? You got it. AC and BC. I'm being so sneaky because it's not what we would expect, right? All right, so now that we know which two sides are congruent, now we can label. It says that AC is 45x plus 8, that AB is 30x plus 40, and BC is 50x minus 2. Can somebody help me think of an equation to solve for x? Sebastian? Excellent. Because these two sides are congruent, I can set their expressions equal to each other. So now we're going to solve. So I'm going to subtract the 45x on both sides. So now I have 8 is equal to 5x minus 2. And because I'm now solving for x, I'm not going to bring the 8 over, right? I'm not trying to bring more things over to x. I'm trying to bring things away from x. So I'm going to add 2 on both sides. So then we have 5x is equal to 10. And then we divide by 5, and we get x is equal to 2. And then lastly, we want to find AB. To find AB, we're just going to plug in 2 for x. So I go to side AB, and I have 30 times 2 plus 40. Well, 30 times 2 is 60. 60 plus 40 is 100. So AB is 100. Okay, so this is where we stop.